Hello everyone. In previous lecture we had discussed about the thread and multi-threading models. Now in this lecture we will understand how we can use the fork and EXEC system calls, and we will understand the threading issues. So before I start this, you might be knowing about the system call. If you don't know, go back and watch my previous lecture and you will come to know the system calls. So we have already discussed about the system calls. Now, before we start the threading issues, we have certain issues in the threading. We will address those issues. First, we are going to discuss the fork and EXE system call. Now coming to the fork system call is used to create a separate duplicate process. Means the fork create a new process, or duplicate means the child process. So these fork and EXEC system call works on Linux operating system, and fork is used to create a separate and duplicate process. The meaning of the duplicate is creating a child process, right? So creating a new process and creating a child process, we use the fork system call. Now, similarly, there is EXEC. When an EXEC system call is invoked, the program specified in the parameter to EXEC will replace the entire process, including all threads. Now, EXEC is invoked. We need to pass the parameter which will be another program. So when we invoke this system call, so program specified in the parameter to EXEC will replace the entire process, including all the threads, which means it will replace by the other process. It will replace with other process or another process. So EXEC system call put the same process ID, but the contents are different. Means we will be getting the different contents in the EXE when it replaces the entire process, including all the threads. It don't keep any existing process threads, so it replaces entire process with all its new threads. So EXE replaces the current process code and data with the code and data of a new program specified as argument. So no process duplication will be taken place in EXEC. Means it doesn't create a new process. Okay, as like a fork create a new process, right? And it returned to both parent and child. So process ID, that is the parent ID, and the child process will be created by fork, and the process tree becomes a parent, and the new child of the process is establishing a process tree. Okay, whereas this EXEC replaces the current process along with the code and data of a new program specified as an argument. So that is the meaning of this parameter to EXEC will replace the entire process, including all thread. Means it doesn't create any new process. No process duplication take place in this. Commonly this fork create a process, while EXEC replaces the current process, and fork return both the parent and child, while EXEC does not return parent and child. So fork is used to create a new process. EXEC is often used to replace the process with new process. So I hope this is clear for can EXEC. Now let us move to threading issues. We will understand the threading issues. Now first of all, if one thread in a program call fork, does the new process duplicate all the threads, or is the new process single threaded? Means if one thread in a program call, that is fork, does the new process duplicate all the threads, or is the new process single threaded? Then there is a solution for such issues is some unique system have chosen some unique system have chosen to have uh, two versions of fork, one that duplicates all the threads and another that duplicates only the thread that is invoked the fork system call. Means we have two versions of fork, that one duplicates all the threads and another that duplicates only the thread that is invoked the fork system call. Now, if exec is called immediately after forking, means after the fork system call, if immediately exec is called, then the duplicate or duplicating all the thread is unnecessary. So as the program specified in the parameter to exec will replace the process, because exec will replace the entire process with its all threads. So in this instance, duplicating only the calling threads are appropriate. Now, if the separate process does not call exec after forking, means we are not calling calling exec after forking, then what happens if the separate process does not call exec after forking? Means then the separate process should duplicate the thread. Okay, the separate process should duplicate the thread. So this is how we can get the solution for this kind of issue. This is only one issue we have right now in the threading issues. So hope you understood this fork and exec. So in next lecture we will discuss some more issues regarding the threadings. So thank you for watching.